This is the Simpleware software that you're seeing in front of you with the raw data from a production case in the system. We're just viewing in 3D a volume rendering of that grayscale data, and you can see these potentially difficult areas for segmentation that is highlighted. What you can see in the top left-hand side of the screen is the automatic setup that has been built that allows essentially the segmentation and the comparison with ideal component, and then the defect detection. Now, while this is running, I should say that just for demonstration purposes, we have each of these capabilities separated into different buttons, but that is purely for our demonstration. What we've seen and what we've tailored in the past is a completely automated process that runs in the background. So our solution can be run from command line and can be run headless in this circumstance. So solutions can just be brought forward to an inspector when required, rather than this process having to be run. Essentially, this sort of process could be set up just following a scan, and the solution could run in the background before being presented to the inspector. So what you can see now on the screen is the result of the automatic segmentation that was built using all of the wonderful data that was provided by Avonix. And you can see that it's very robust in its ability to capture all of the complex data that we saw, and even some of the data that was noisy. And what my colleague Matt has been able to do at this point is run a comparison between our ideal reference model, which I described earlier in terms of how that was built. And then by completing this next step, we're able to show the deviation between the two and identify those different areas within the tabulated form of defects. So you can see in the image at the bottom right that we're visualizing the deviations, and by adjusting the sensitivity, as Matt is doing on the left hand side, we can find these tabulated defects and identify them automatically. And as I say, this tool is meant to aid an inspector to run through the data and to provide another form of validation of the defects. It can help get to these defects more quickly, but we fully expect the rest of the data to be viewed as well in that inspection process. Here you can see in the 3D view the defect highlighted as well, with the deviation categorized with its scaling in this sense. I should say at this point that this is very specific to the turbine blades that we analyze within this process. So it's not a generic tool. It's very focused towards a specific application. But this sort of strategy can be taken with our customers directly to build these solutions for them.